welcome. I'm super excited to introduce you to Thanos, so an open source Prometheus-based monitoring system that I just happened to maintain. And this is kind of a special event because I was presenting this. We're talking about Thanos in many places, many times. In London, Munich, Brussels, Edinburgh, even Los Angeles. But I never kind of have an opportunity to talk here in my home country. So I'm super excited about that in Warsaw. So I hope you will like that as well. Short introduction. My name is Bartłomiej Płotka. I'm a principal software engineer at Red Hat. And I'm currently based in London, and I'm kind of a long time in the monitoring observability infrastructure space, and this is kind of because of my previous role as a kind of software engineer / SRE in UK-based startup called Improbable, and I had like lots of opportunities to get into love with monitoring, with infrastructure problems, and open source as well, and that's why I kind of joined Prometheus core team, and we started Thanos on the way. So yeah, that's me. And before we move to even Thanos, let's talk slowly about do we even need monitoring, right? And I hope I don't need to repeat that, but it's always worth to reiterate over this very important message that you kind of, this is something I heard in my first day when I was deploying something on production or creating some product, that running a product without any monitoring is like not running it at all. And you might think this is as bit cryptic and like maybe over engineering or something. No, it's literally true. Like if you want to run something, you probably want to make sure that it's running without any downtime or like limited with the highest possible availability, and like you need to met your SLAs. And without monitoring, you don't have any way or any tool to say if it's running. So it's really important. And this is also what you can read from the SRE book. You can see like the kind of Maslow pyramid, but for infrastructure needs rather than human needs. And yeah, monitoring is like the foundation of the whole stack. So, and this is because you need to have monitoring to, for alerting and detection mechanism, ability to debug deeper if needed, maybe see some long-term characteristic, and make data-driven decisions, which is awesome. And maybe finally automating those decisions in some way. For example, maybe autoscale if you are running out of the CPU or memory or self-healing. So it's very important. Now, probably you know about that already, but you can divide kind of monitoring into different ways, different signals, and different types of information. And those are like basic ones. So you have a tracing, which is any byte or kind of byte of data, metadata, which can be bound to a life cycle of kind of transactional single request in a system. If the request comes through various services, it's called distributed tracing as well. Then you have logging, which is essentially represents the discrete event, and finally metrics, which are essentially as samples over a span of time, which you can kind of compose into logical counters or gauges, histograms, and you can aggregate over those. Now that's not the end. You can grow more. I mean, you can have many more types of information. And one thing that I found really interesting is continuous profiling, for example. And there's actually one initiative in my team. So Frederick Ranchik, who I work with now, is like creating this ability to have this signal, which is continuous profiling. So you can imagine that you are periodically grabbing the profile of the applications over time, and this is super useful because if you have some issues, for example, memory leak or CPU spike, and you want to debug this, and you gather kind of the snapshot of the profile in the current moment, it's actually too late. Like service probably already. You have problems to kind of get this data from past. That's why this continuous profiling allows you to kind of gather those profiles, memory dumps, CPU profiles, go routine heap or whatever kind of dumps, So yeah, this is like another signal. So it's not only tracing, logging, and metrics. And in fact, it can grow even further. So who knows what else would be in the next years. Anyway, let's focus on like some use case of those. So this is like a typical troubleshooting journey for developer, for SRE. You first, kind of use metrics to trigger an alert. This alert like wakes you up. Now you need to kind of act because something is going on. You probably go first to, alerts should link to some playbook, runbook, and to some dashboards, which are, usually in Grafana. There are like statically configured graphs that are fetching metrics as well. Now you kind of maybe know what's going on, but you want to dig further. You can go to ad hoc querying. You can go to any metrics backend and actually query it with customized query. Then you hopefully know what service or like what operation failed. So you go to logging, right? You go to your logging backend, Elasticsearch, Loki, whatever. And furthermore, you maybe touch tracing as well. So maybe you narrow down to single request that failed, and you want to check what operations those requests were doing, what services it was touching, and how much time it took for each operation. And tracing helps with that. And finally, all of those things helps you to fix the problem and mitigate the problem that we were alerting on. Now, today we'll focus on those kind of three elements. So, and this is because those three are backed up by metrics. And as you probably know, like one of the solutions for metrics in this space, in open source space, in communities, is Prometheus. And because Thanos is essentially Prometheus on steroids, like we use Prometheus internally, we use kind of Prometheus libraries, we reuse the code, we have the same kind of native format. It's super important to talk about Prometheus first and why we even choosing Prometheus, right? So can I ask you some questions? First of all, please raise a hand if you heard about Prometheus. Yes, I hope for that. Now, who runs Prometheus on production? That's awesome. It's like half of it. So okay, so I'm not sure, like because I wanted to talk about some basics, but let me quickly go through it. So first of all, Prometheus, as you know, is a very simple application, a binary that you just run on the cluster, and is capable to pull the metrics from your application and use it, and allows to use those metrics in an efficient way later on. Maybe you want to query directly the database, maybe you want to have an alert, maybe you want to have a dashboard in Grafana, which uses metrics from Prometheus as well. So this is all super useful. But what's special about Prometheus is that in the goal of the Prometheus is to not have a separate, monitoring team to operate Prometheus, right? It should be just fire and forget. You just run it, and you have monitoring. It's super reliable, but you are not really looking into fixing this all the time. You don't have a separate, team that operates the Prometheus. That's the main idea. It should be simple. That's why it's a simple binary. As by design, like Prometheus team, so we are not trying to make Prometheus distributed in any way. That's why you have just one database, which is TSDB. It's never replicated, never back up. It's actually super focused on its goals. And there is a benefit to that, right? Another thing is that it's super powerful. Like as a single binary, you can hold of 10 million series easily. We've given memory and CPU and some disk. So it's quite powerful as a single binary. One more thing about kind of push versus pull model, it's worth to mention that Prometheus has a pull model. What it means, it just usually any monitoring solutions are pushing metrics. And Prometheus does totally opposite thing. And I really love that. That's why we chosen Prometheus like internally back then in my previous role, and that's why I'm kind of promoting this vision, is because pull model is much, much better for those use cases. First of all, it has kind of three benefits, main benefits. First of all, backend is just easier to operate and maintain because you don't need to worry about, kind of a client abusing the server, so maybe pushes too much, too many requests, maybe retries, maybe DDoS you. It's super hard to control that. That's why if you pull that, you have consistency in interval of those pulls and sampling, and you are on control of how often you do that. So it's just harder to abuse this system. Secondly, it kind of allows Prometheus to have near real-time kind of analysis and access to the metrics. If you push metric, well, you go probably through different buffers, you have network unavailability, things like that. Sure, it can happen here as well, but just easier to maintain this real-time characteristics. And last but not the least, application code, client code is extremely easy to just write. So you have only a simple, so this application on the right, it needs only a simple HTTP server just to expose, metric page in a plain text, and that's it. And you need to only instrument those metrics, and those will be exposed to Prometheus, so Prometheus can fetch with some interval and grab those metrics, right? Versus imagine if you'd like to push in some other systems, you have lots of problems because your client suddenly needs to care about service discovery, suddenly needs to know where this push endpoint is. That's the first thing. Secondly, what about network unavailability? Now maybe I should retry. How many retries? How many maybe I should buffer things. And what if I crash? Should I flash the metrics I used to have to not lose them or something like that? And suddenly your stateless application is stateful. And well, that's the whole point of having Prometheus in each cluster and having it to pull metrics. So it's really nice in my opinion. And yeah, last thing, Prometheus is very popular, as you know. I don't need to explain that. Cool. So we talked about Prometheus, how powerful, how amazing it is. But so why we even build Thanos? So why do you need to extend that? Well, it is extremely powerful and reliable and super easy to operate if you have one Prometheus. Now, what if you want to scale out at some point, right? And you have more than one? Well, then things can get scary, and we will talk about the problems that we could have while scaling out Prometheus. But first, why we scale out Prometheus? Well, there are kind of three, let's say, reasons for that. You have, well, first of all, maybe you should have kind of high availability in Prometheus space, which means that you run two replicas of Prometheus scraping the same applications. So they exposed exactly the same data. The database has exactly the same metrics. So whenever one is down, you can just use another one and things like that. And that's pretty must-have, in my opinion, because finally you can have a rolling restart of the Prometheus, which is a kind of crucial thing, for example, in Kubernetes. Second thing is scaling ingestion. Like, as you know, Prometheus, sure, can handle millions of series, but having those huge machines are usually not the case. Like, you don't want to spend so much money on huge VMs, so maybe you'd rather shard Prometheus into smaller instances and have the Prometheus to only scrape part of the applications, and then second one will scrape part of the application as well. So that's another use case. Why would you scale out Prometheus to multiple servers? Now, last but again not the least, is very important. We are living in cloud-native world, and nowadays creating a cluster is super fast. Like creating a Kubernetes can be within minutes. You usually have multiple of those clusters because you want to some geolocalizations. You want to run something in China and US, so you would have more than one cluster, and that means you have more of one Prometheus, because you want to have Prometheus in each of those clusters, because Prometheus works the best if it's in the same failure domain as the cluster itself, because it's kind of connected to the metric it scrapes. So yeah, at the end you have multiple Prometheus instances. So now is the question, why is that a problematic thing? Well, let's think about this use case. I want to kind of have a query that will return me a number of series I have overall in all of my Prometheuses, right? How do I do that now? Well, I probably need to kind of ask each of those Prometheuses, ask how many series you have, and then manually kind of aggregate that or render in one graph for easier kind of seeing of this value. But you can't action on this. You cannot have an alert. It's manual, and like it doesn't work. This exact problem is called global view, lack of global view. So there is no global aggregation in Prometheus that will solve that. Now, it gets more tricky if you have this HA use case, right? When you have some of those replicas are actually scraping exactly the same data, and they are part of the same HA group. This means that it's even more tricky to understand those results, even if you would naively iterate over all Prometheuses to gather the required data for our aggregation over all series. So, that's another thing that we want to solve. And the last one is retention. So this is, first of all, you don't really need that all the time. However, it's very useful to have long retention, right? So you would like to have a long query that you want to query for something that was happening over 1 year, and you want to see what was happening. Or maybe you want to see what happened 2 years ago, or things like that. It's super useful to have that. But obviously it costs. And it costs a lot in Prometheus, because you need to kind of manage kind of huge disks, persistent disk. You need to, there are lots of problems of maintaining this, because you need to kind of resize at some point those disks, or maybe backup those, or how if you crash, if you lost the disk, how do you kind of recover from such crash? If it's like 2 years of data, you'll wait forever for this Prometheus to kind of start up, things like that. So it's not easy. That's why, well, this is also a problem. One more thing to that is that even if you would manage to have such huge disk, you can't query 1 year query range. This is because there is no downsampling. This means that if you would query such a long range, you would have so many samples back, because the resolution is so kind of low, that you would blow probably every component on the way, including your browser, right? And you possibly cannot have all those samples, like human cannot even watch this. So it doesn't make sense without downsampling to query such long queries, such long ranges. That's why any downsampling would be useful here, but there is none. Cool. So all those 3 reasons, like a lack of global view, maybe lack of proper handling of HA, and long retention, is why we created Thanos. And just to mention this, this is not like imagined problem. Like we were having those issues at production. That's why we created this. We don't want to sell Thanos. It's like purely open source. There is no like one company behind that. Like we are literally, it's a joint effort to do something right and have that usable, and finally have a proper solution for Prometheus on scale. And that's why I really like to work on that, and that's the whole idea. So we started Thanos like 2 years ago with Fabian Reinhardt from CoreOS at that point. And yeah, we are maintaining this project up to now. It was fully open source from the scratch. We are in the CNCF sandbox recently. 2 months ago, we got accepted, so that's pretty cool as well. It's super helpful to be there. It's a kind of healthy community as well. So by the way, visit if you are in KubeCon in November, I guess. We'll be talking about Thanos as well. We'll be there as maintainers, so that's pretty cool as well if you are joining us. Cool, and yeah, we have kind of, we are lucky to have nice community as well, lots of contributors, and yeah, kind of diverse maintainer kind of team with 8 maintainers, different roles, 7 different companies, so that's I'm super happy with that as well. Cool, and one thing to mention is that I had 2 questions yesterday during this conference, like, is Thanos production ready? I mean, this question was valid maybe a year ago, but now, like, clearly it is. We were running Thanos in production for 1.5 years already, and all those companies are running on a high scale, especially Alibaba, who's like Chinese kind of data compute platform, right, on a global scale, and they really have a nice kind of presentation on KubeCon Shanghai about Thanos as well. So yeah, also those are only some production users as well. So yeah, I think we are super grateful that there are so many nice companies that help us building this product together. Cool, but that was quite long introduction, and now we are actually starting with Thanos and how to transform, kind of example scenario when we have 2 Kubernetes clusters and a couple of Prometheus servers into Thanos within 7 steps. And just to keep in mind, we are solving, all 3 issues we mentioned: global view, lack of global view, lack of HA, and short retention that we want to make it longer. Cool. So first step, we need to add some kind of sidecar. So this is Thanos sidecar. It's a special component, a binary that you just run next to your Prometheus server. And it has multiple of kind of features, but one of those is it exposes a gRPC endpoint called store API, which essentially translate Prometheus API metrics to something which is called store API that is understandable by other Thanos components. Why we do that, you will hopefully understand that in following slides. So it translates the kind of the metric API, and also it has like nice features. For example, it can reload your Prometheus configuration or recording rules or alerts immediately, reload from config map. So that's something that was not really solved in Prometheus. You can reload from the file, but you need to kind of poke Prometheus. Like Sidecar allows to do that. There are some other features like this config map with Prometheus configuration can be compressed, can have some environment variables that we will substitute. So it's pretty useful, in my opinion. Now, step 2, we are adding a global component in any cluster you want. Can be in one of those, can be in separate cluster, which is, and you add a component called Thanos Querier. It is purely stateless, and it allows you to connect to any number of store APIs. And that's why we kind of invented a new API, which is like a gRPC API. It's because from query perspective, it doesn't matter what is behind this API, like what implements this API. So it can be Thanos, so Prometheus and Sidecar. It can be anything else. It can be OpenTSDB. We have integration with that as well. So that is pretty flexible, I would say. Now, Querier connects to the store API and essentially allows us to kind of perform our query that we like to do. So this is kind of the way how you solve the global view and high availability, right? Because now I can query just for how many series I have from all of my Prometheus instances. Since Querier has access to all of it, just grabs this and aggregates on the global level, right? So now the Querier is doing the PromQL evaluation, not the Prometheus itself. And thanks to that, we have the global aggregations. Now, with the high availability of Prometheus, it also handles that seamlessly because it has this deduplication layer, the duplication step, let's say, when it kind of detects which Prometheus instances are within the same HA group, and you configure that with external labels, essentially, from Prometheus. So you just add a special label called replica, and thanks to that, Querier knows that if there is replica label, it can deduplicate and transparently show to the user like it is one Prometheus. So that's pretty helpful in this case as well. Now, very important thing to mention here is that you can actually use Thanos like this. Like you don't need any other kind of components, things like that. If you want to just focus on the solving global view, lack of global view, and high availability, things like that, you literally can just stop now, and just install in this way, run on production, and it will work. So some companies from those you have seen are running like this, for example. They don't even go beyond that, and that's pretty useful for Thanos because it allows this gradual installation and kind of flexible in deployment model as well. But let's say we want to be ambitious, and we want to have long-term retention. I want to check what happens a year ago, or maybe query how my CPU profiles, CPU seconds for my certain service looks like for a year. Now, to do so, we need more steps. Step 3 is configuring Sidecar to upload blocks to the object storage. So you add some object storage, and Thanos supports many of those. Obviously, AWS is free, GCS, Azure, OpenStack Swift, but also, kind of Ceph, Minio, and China backends as well. So with this in mind, you essentially configure Prometheus or Sidecar to upload to the object storage. The important bit about that is that it's not streaming. It's a lazy upload. This means that you don't need to have really, high bandwidth, very reliable network connections to object storage. It will upload in a lazy way, so you can kind of be prepared for any kind of an unreliability on the network side. And what is happening inside is that Prometheus is gathering metrics, collecting them. It is gathering them in memory, let's say, for 2 hours, and then every 2 hours it produces the block, TSDP block that's how it's called, TSDP block, which is a format of storage for Prometheus. Now, Sidecar watches those and uploads those blocks in the object storage in exactly the same format. So if you would just gather so many blocks like for 2 years, and you grab the one block from object storage and just manually put it on Prometheus into Prometheus kind of data volume, this will work. Prometheus will totally understand this object and will serve you the metrics from that period. Now, step 4 is to actually be able to use those metrics, right? So now we add a store gateway, which is another Thanos binary, and you essentially configure Queryr to add another store API. That's it. And thanks of that, you can query both fresh metrics, so up to 2 hours from Prometheus's, and old metrics which are in object storage. Now, one more thing that I didn't mention is that thanks of this architecture, the Prometheus servers can be reduced, the retention of this can be super reduced to 6 hours. So nowadays, this is super useful because they are super lightweight and easier to operate because they are just smaller. And so you can imagine that now, instead of 2 weeks or something like that, you have just 6 hours on Prometheus, then you upload REST on the object storage. So everything beyond 6 hours is available thanks to the store gateway. And because object storage is managed usually, it's easier to backup. You can use kind of many providers that gives you the object storage. It's cheaper as well. You can essentially have unlimited retention, and that's what we were doing. We don't have even any retention on our metrics, and that's pretty nice from our use case. And the last step to enable long-term retention is this compactor component. So that's another thing that you run as a singleton, and this essentially reduce cost of storage even more because those blocks that you upload are 2 hours. Now you want to maybe compose them and compact them into bigger blocks for easier lookup and kind of size reduction. But there is also a very important thing additionally to compaction. Compactor also downsamples your data. So once you run the compactor, it will run through all your blocks and downsample, which means that it will reduce the resolution without really reducing the precision of your metrics. And that's pretty neat because now when you query something from Queryr and you query for 2 weeks, it will automatically choose something that is reasonable for your graph. So probably for 2 weeks you will you will not hit downsample data, but raw data, because it's kind of you maybe want this resolution for such short query. Now, if you query for 2 years, it will automatically detect that and will actually fetch only downsample data, so the query will be pretty quick. Cool. So I kind of promised 7 steps, I have 5, and that's maybe a problem. So let's play with it more. Let's extend it even further. So now all of those kind of steps, well, 2 steps I want to talk about are super optional. It's just additional stuff you can add on to your Thanos. So essentially, one of the things is that what if I have an alert that requires the data longer than those 6 hours that I have in Prometheus? Then you need to have some kind of global component, component that works on the global query that has the data, the kind of access to the old Prometheuses and old data storage. So Yeah, and ruler is essentially a piece of Prometheus just exposed as a single service, and it allows to periodically query the querier for the data you want. But the thing that's very important here is that you really want to have your alerts and recording rules inside local Prometheus as you used to do. Like, don't change that. However, if you have special alerts, yes, you might want to spin up something like this to essentially have alerts that are a bit special, requires maybe global aggregations, data from different clusters together, things like that. And optional step 7, this is actually super new. I never shown that before. We organized Prometheus London meetup, and a month ago we had a very amazing, so amazing talk from Tom Wiki, and we are working together with Tom for a long time as well in Prometheus ecosystem. He's Prometheus maintainer as well, and he's maintaining the Cortex. Cortex is a very similar solution to Thanos. However, it has totally different use cases and bit different design. It is purely remote write streaming solution versus Thanos has like more flexible choices and maybe a bit simpler installation process. Now, we actually work together, so they kind of cut off from the whole Cortex a very useful feature, which is like query front end, a caching response, and that's extremely nice. So I will give those slides somewhere so you can like click and see the talk and like how to set up this. But essentially, what it gives you is you have a caching layer on top between your Grafana servers and Query, but also maybe Prometheus or anything. It will work in any form, and thanks of that, everything, every request is actually there are like pre-processes here and there. So for example, each query is actually split by day, it's aligned, and this gives you ability to cache it properly, to cache it nicely. It's highly cacheable in this way. Then you store it in the memcache, which is like a best effort. And you can imagine that you have Grafana dashboard, and it's always the case where you maintain this kind of Prometheus Thanos cluster, and you have interval of your metrics, which is 15 seconds, and someone puts a refresh rate of the dashboards for 5 seconds. So every 5 seconds, even though there is no use case for asking backend for metric that often, it will actually produce lots of unnecessary load on your system. Thanks of caching, most of those things will be cached. So that's pretty nice, and I really recommend to look on that component, and we are running on that on production slowly soon as well. So yeah, that's from extensions. One last thing, there is like a third deployment model of Thanos. It's this Thanos receiver on the left. So maybe, right now we have kind of 3 options. Either you query the Prometheuses, either you upload in a lazy manner, or you stream. Because nowadays Thanos also supports the remote write streaming. And this is because some use case, for example, you have customer that you want to give him kind of ability to have metrics, to host metrics, and this customer has on-premise cluster that kind of is secret or like confidential, so they don't want to allow any request to fetch data from, right? However, they're fine with pushing data. So in this case, Thanos receiver is very useful. Cool. Now, live demo? Well, maybe not. And this is because as a Thanos team, we kind of discussed this because, I presented demo kind of many times. It is nice. I think people like that, but I think I prepared something better for you. This is because if you think about this demo, it's just one off demo. You just show it, but it's hard for you to just play with it, right? To just run it on your own. There are different, distributions, like you can have different use cases. So we thought about something better. So we started, and literally I prepared that for this event. So we merged that yesterday. Those are interactive tutorials on Katakoda platform. It's like an amazing platform where you can have kind of play with the solutions like Kubernetes, Prometheus, Thanos from your whole browser essentially. So you go there, you have a couple of courses. Right now, it's like only first one is ready, which is like essentially this global view. And REST will be adding will iterate over it and adding in meantime. However, you can immediately, even now, just open on your phone, log in for free, play with Thanos on your phone. Like literally, this will work like that. So if you click there, you have this kind of mix of terminal and editor and some tutorial where you can click on those commands that will spin up a Docker. It will automatically go to the terminal and will run this. And we try to explain everything. So I think it's much better than live demo because you can actually play with it live even now. So I really recommend to go there. It's pretty, I just merged that yesterday. So if you have any feedback, just give us, go to Slack, talk to us, and yeah, we'll be improving that over time. And yeah, thanks for really thankful for the community to help us to create this. It was not only my work, it was joint effort, and also for Katakoda, who helped us to spin up things and actually made custom features for Thanos. So it's really amazing platform. It's for free, so go for it. Okay, short notes about future maybe of Thanos. That's, I think, one thing that we are super focused in the following months. We want to maybe allow mutating all data. So there is something in Prometheus like delete series. So you have, kind of the whole block, and you want to only delete one particular series from that. And yeah, you can't do that from object storage right now. We want to allow this. We want to improve resource consumption. So you want to reduce cost of running Thanos. Multi-tenancy is the thing. And yeah, there is no downsampling in Prometheus. So it would be really, really nice to contribute that if this will, I mean, it seems that it's working well, so why not contribute it to Prometheus itself, Prometheus can have long retention as well in some cases. Now, we also be working outside of Thanos about different signals and maybe, even incident response improvements. There is lacking in open source space for solution for that. So yeah, looking forward to that. Cool, so what we learned, let's summarize. We talk about monitoring, why it's super crucial. We talked about Prometheus, what is it, why it's nice, why do you have pull-based solution, not pushed. Then we talk about 2 steps for Thanos to solve global view and HA, and you can just have this and don't go further. We can add by doing 3 steps more. We can add long-term retention solution, and again, you can mix all of those things. For example, you can have in one cluster only use Prometheus and Sidecar. In some clusters, you can upload to object storage. You can just compose any kind of deployment you want. And we talk about extensions like ruler, caching, streaming option. And yeah, a demo. So cool. Thank you. That's it. Some links, and join us, our community. You have a Slack link to Slack here, and yeah, give us feedback. Thank you.
If I understand correctly, the Thanos is exposing the same Prometheus API. The second, so that means that instead of using Prometheus in Grafana, I can just point it to the Thanos?
Exactly that. Even more, Querier has its own UI that looks literally like Prometheus UI and has some additional buttons, but you will have the same experience. You can go directly to Querier. It has similar UI, so yeah, it will look kind of the same, yeah.